We'll start with the introduction. First of all, if you have seen good programmers, they would have started with C. What is the power of C? And we'll talk about the existence, the development, and still the strongest presence of this language amidst all other languages which we are going to see here and there whenever we talk about C and compare them. First of all, these all languages, they have special tasks. C has also special tasks. What is C? C is a programming language. You can say it's a general purpose programming language. So it was developed at AT&T Bell Labs of United States of America in 1972, and it was designed and written by Sir Dennis Ritchie. And there were various familiar languages, famous languages, PLI, ALGOL, and after C evolved without even any advertisement, though it was not even made the official Bell Labs language, without even advertisement, C's reputation actually went many-fold, and people, actually the developer community, they started to use this language, and it has gone above all those languages which were used at that time. C is the most popular. Why? Because it is reliable, simple and easy to use. Please mark these words because we'll be going to see them in quite detail. And say a language is still there. We are talking in 2018 and still this language is so strong. That means it has something in it. That is why people are still using it. Everywhere it is used. But there are things which we heard that C has been already superseded by C++, C#, Java. There are so many languages which has come. So why to bother learning C? So let us see some point on that. Our take on that. First of all, these all languages, C++, Java, C#, these are high-level languages. They have a concept behind them. And these concepts are classes, objects, inheritance. And these are not programming. These are not programming. These are the concepts basically. These are object-oriented paradigms. And in order to, first of all, you ought to know what a language is. Basic construct of the language you should know. And then you can go ahead with all these added advantages. That is why C, if you take as a base, then you can go ahead with all these languages and there will be no time to learn, means you will take no time to learn all these languages and those languages which are coming up. Then we have this C++ and C#. These are, as I said, just object-oriented programming languages. So they are offering some advantages, and people were saying that C has some limitation. That is why these language has come up. But this C is going to give you a basic building block or programming skill. It will be there to enhance your skills. Now then we have Java. It came and there are various frameworks which are being coming, and they said we'll provide this. Java said okay, I'll provide you the bytecode, so I'll give you a program which is platform independent. But still C holds that it's still been unchallenged because of the performance it gives, because of the easiness it gives. One more thing that you will appreciate, that all the popular operating system you are aware, Windows, Unix, Linux, they all are written in C, and that is I think that should be the conclusion. Because if operating systems are being written in C, C has to be, so performance wise crucial, good, and the speed of execution of C programs are so good, and mostly the device drivers are also written in C. If you talk about your washing machine, your cellular phones, your microprocessor, operating system, embedded systems, mostly the programs are written in C because the performance it gives, the execution ease it provides is incomparable. And all the 3D games, mostly the 3D games where you want instant output, in that you will see that most of the vendors of frameworks, underlying frameworks, there are in C language. Because C is very close to hardware. It is closely interacting with the hardware. That is why we have, just because the performance it gives, other languages might not give that. So these are few reasons. That is why you should learn C. Even if you don't have a subject in your curriculum, and if you want to be a programmer, if you want to learn programming, I suppose this is the best time, this is the best way you can start. So whenever we talk, that is I am talking in English, most of you might be understanding what I am speaking. That is, I am speaking in a language which is known to you. In this similar way, when we speak to computer, how to let computer know that we are saying the computer something. Computer doesn't understand anything. It only understands 0, 1, 1, 0 like this machine language. For that, what we can write a program or write some instruction in high level languages like C or any other programming language. Then we have a compiler. Compiler does what? It changes that English like sentences or English like instructions into the machine code, and that machine code will be understood by the computer. So basic is that you ought to have certain way, because if you see you are a kid, very small kid, then you start with alphabets. You don't jump to paragraphs. You start with alphabets, then you start speaking word. You see a 3-year-old or 2.5-year-old kid, he'll be able to speak words. Then after that, he'll be able to, after 3.5 or 4 years, he'll be able to speak sentences. He can speak sentences, and then after that he'll be able to say paragraph. Maybe 6 or 7 years he is. So this is the stage. Similarly, when you are learning C or any other languages, this is true to any other language, like alphabets, digits, special symbols we'll be talking about. These are the basic building blocks. If you combine them, alphabet, digits and special symbols, it will become constant, variable and keywords. Then when you combine these, it will become instruction, and then the various instructions will make a program. So this is how your program will be there. And if you say some paragraph, write some paragraph, he'll be able to understand certain things. Similarly, if you are able to write some program in some languages, some syntax which is governed by some language compiler, then that computer will be able to know what you want to speak. So we have C character set. The character set means the way English has some character set A from Z. Maybe your language may have some character set. So the character which denote any alphabet, digit or special symbol is used to represent information in C. These are the valid alphabets. These are the valid alphabet, capital A to capital Z, small a to small z. These are all the valid alphabets available. Then we have digits. What is digits 0 to 9? These are the digits. Then we have special symbols. These are all the special symbols. If you want to say put if else in ternary, you will use this question mark. You want to multiply into two numbers, you will use this star. All these are available and we'll be using them immensely. Then we have constants, variables and keywords. The alphabets, numbers and special symbols, when they are properly combined, they form constants, variables and keywords. So we'll see what these constant and variable are in C. So constant is an entity that doesn't change. Constant means, if you say the GDP of the country is constant, that means that GDP is not changing. It is varying. That is why variable has come from the word vary. That is, it is changing. It is not changing. It is fixed. So what happens here is, the way we understand, we think something, we see something and we keep it in our memory. Similarly, in computer also there is a memory. So whatever it learns or whatever is being fed to him input, it is being given to it and it keeps it into the memory to recall it sometime. I'll show you with an example. The variable means X. X is a variable and it is just showing that this is a memory location which X is named. This is a location, or say your house is known by an address. Similarly, this memory block is known by this address which is named as X, Now this 3 is put in this memory location. Now what can happen? You can place 5 here, you can place 50 here, you can place any number here. So this value can change. X equal to 3, now X is replaced by 5. That is why X is a variable. X is a variable means it varies. It can vary. So the location whose name is X can hold different values. That is why it is called as a variable, right? What are the type of C constants? These C constants, they are divided into two categories, primary constant and secondary constant, and they are again subdivided. Like C constants, primary constant and secondary constant, and the primary constant can be integer constant, real constant and character constant, while the secondary constant can be array, pointer, structure, union, enumeration, enum. We'll be talking about these separately. At this point, we'll talk about the primary constant like the integer, real and character constant. Let us see them in detail because there are certain rules of making them. So what are the rules? The rules for constructing integer constant. If you are saying that I'm making an integer constant, what are the rules? The rules are an integer constant must have at least one digit, then only it is an integer constant. Then it must have a decimal point. it must have a decimal point. It can be either positive or negative. If no sign is there, you will assume it to be a positive. No commas or blanks they are allowed in your integer constant. No is allowed. And the allowed range is this of integer constant. Now this is a question of discussion because this depends on a compiler. See, if you have a 16-bit compiler, 2 to the power 16 is the range. That is, you take half of this on the left hand side, that is of the number line, half on the right hand side. So these are 16 bits. Say if you have Turbo C or Turbo C++ compiler. But if you talk about 32-bit compiler, it will be 2 to the power 32. This kind of limit will be there. But we will stick to just now 16-bit, okay, just for discussion. So these are all your valid integer constant. These are all your valid integer constants. What are the rules of constructing real constants? What are the rules of constructing real constants? Real constants, they are called as floating point constant also, and they can be written in two forms. First is your fractional form, and then you have the exponential form. And what are the rules that govern the real constant, making of real constant? The real constant must have at least one digit, as we have seen in the integer constant. It must have a decimal point. It must have a decimal point, and it can be either positive or negative. And the default sign is positive. No commas or blanks they are allowed in your real constant. And these are some examples of your real constant. This point, the decimal shows that it is a real constant. The exponential form, when you are trying to represent some value which is very small or very large, very small, very large, then you can't just write it like that. Then at that point you write it in exponential form. So the exponential form of representation, the real constant, is represented in two parts basically. You have a E that shows exponential. You have a right one, you have a left one. So the left one is nothing but the mantissa, and the right one is, this is the mantissa, and this one is your exponent, right? So these are the rules which we need to observe while we create real constant which are expressed in exponential form. So the mantissa part, that is this part, and the exponential part should be separated by a letter E. This is the letter E. And this mantissa part may have a positive or a negative sign. The default is positive. The exponent must have at least one digit. This should have at least one digit, which may be positive or it may be negative. So range of this real constant is expressed, this exponential goes from, see, it's a very wide range, minus 3.4 e to the power 38 to 3.4 e to the power 38. And these are all valid exponential forms. For character constants, character is only one. The entity is only one. So a character constant is just a single alphabet, a single digit, or it can be a single symbol, which are enclosed between comma. But this comma should be both left side. This way. This should be left side, not this type. This is not a constant. This should be always left wise. So the maximum length of a character can only be one. It can only be one. Right? So these are all single value, single digit, single symbol. These are all character constants. Now we come to variable. Variable means these are just the name of the location, memory location where you keep something. So how to name this? What are the variables? What are the real constants we have seen? But there are rules, certain rules how to make these C variable. So variable name should be something like this. A variable name can be any combination from 1 to 31. There is no hard and fast rule, because most of the compiler they also give you till 247 characters, so you can go ahead with a long name, but it is not advisable. Stick to small word which is well comprehensible. Then the first character in the variable must be always an alphabet. This is very important. Alphabet or underscore. You cannot start with a number. You cannot start with any other symbol rather than underscore. There is only one symbol which is allowed in the variable name, that is underscore, and then digits and your alphabet. So no comma or blanks, these are allowed within a variable name, and there are no special symbol other than underscore. This has to be understood well, and the name should be quite suggestive, and they should be very intuitive. That means SI underscore INT, that means it is simple interest. M underscore HRA, that means we are talking about some house rent allowance. So the name is a very important concept, because what you are writing is what you are going to see later on and what you are going to give to others. For example, you can't just these are all names, but how to see that what you can put inside these names? SI can have what value can be put? It can have real, it can have character, anything. For that, to just fix this, we put the type, data type here. We'll be talking about data type. This is the data type. So this SI will be of type integer. So SI will only take integer values. This basal will or base salary will take only float values, and code will always take the character value, only character. And then don't put name like A, B, C or X, Y, Z. Just try to put or place the names such that these PRIN says principal. This is rate of interest, this is number of years. These are suggestive. This, even after some time, if you come back, then you know what exactly you have given. Then keywords. See, certain words are kept reserved for certain languages. Means C or C++, Java, they all have some languages, some words which is specific to their languages, and the compiler is advised that whenever this word will come, you have to do a specific task. So you can't use those words. Those are keywords or reserved words for C or any other language. I hope you got the idea. These are also called as reserved words. You cannot use it. So there are various keywords available. These are some few glimpses of the keywords. We'll be talking about all of these in our program, because we are going to make the program, run it in some IDE, say Code Blocks or Turbo C. And there are various compiler vendors like Microsoft, Bol, and there are so many. They also have their own keywords like near, far, ASM. And ANSI committee, they have advised that always if you have some specific keyword, just precede it with 2 underscore. But most of them, this is a question of discussion program. So we'll write the first C program, and till now we have discussed about the variables, the constants, the keywords now, and now we will combine all these in order to make our first program. The first program is always what we call as hello world program, but because we have discussed about that hello world, we'll write some other. We will just add all these components just to make it a little more interesting. So before we actually write the first C program, we need to remember certain things, that each instruction in C program is written as a separate string. So complete C program is nothing but the combination or the series of statements. Then the statement in the program, it must appear in same order in which we want to execute. You cannot have this here and this here if you want to don't want to execute like it. And the blank spaces, they may be inserted between 2 words just in order to improve the readability of the statement, as we'll do in the program. And no blank spaces, they are allowed in or within a variable, a constant or a keyword. And then all statements we will enter in small case letter. C actually has no specific rule for the position at which the statement is to be written, but we'll try to do it in a free form. And this is very important, every C statement must end with a semicolon. Semicolon, this acts as a statement term. So this is our first program. Let me write this first program, and then we will talk about all those aspects which is related to this. This is a bit more than the hello world program, but we'll discuss about this. So what we have to do here is, first of all, let me take you to the code blocks. We'll write our program in the code blocks. So let us say code blocks, and I have already discussed about how to download code blocks, and we'll make our first program. This code blocks is a very powerful IDE. This is an open source cross-platform IDE. The version I'm using is this one, but you can, when you will be downloading, you may be using any of the version, maybe a later version or the latest version you want. So let us create a new project here. We have to create a new project, and then we'll go to the console of application. Let us say go. Skip this for page next time, next, and we'll make a selection C. Let us write some project title, say my project. Then we have to select a folder in which you want to put a file, that C file. So we have I already have made this one folder on my desktop, so I'll be using that. And these two you don't have to touch, this will come by them itself. Don't touch these also. Say finish. When you say finish, and this in the left pane or left part, you'll see that this is the project we have given. And you automatically have this main.c, which is showing you hello world. And these are all the logs and others will come when you run. If there is any problem, that will come here in this region. Let me close it just to give you a better look of this. This is simply a hello world program. First, let me check whether this program is working or not. So I'll just build and run, and I'll see whether the result is coming or not. See, this result is coming. If the result is not coming, we just have to go to the compiler, because it has to, your code blocks has to find the GNU GCC compiler. So just say reset defaults, and it will. Now let me just in the editor, let me increase the size also, because when I'm writing something, you should be able to see what is happening. So let me choose say I'm taking the font size as 20. Okay, no problem. This is it. This is Hello World program. Let me run it again for you, so that this is how you have to make. You have to do #include stdio.h. You can skip this also, by right now. This file has already come. I have not done anything. This has already come because of the you can say a basic skeleton program is there. And this main function, this is a main function. This main function is represented, or how do you know this is a main function? By the braces. By the braces which are following, not braces, but the parentheses. So these are the parentheses. After that we have brace. So these are the braces. So the program execution or program control will start from main, go into this brace and end with this brace. So whatever you write inside these are the instructions which will be executed. See, every instruction is having a semicolon in the end. So every execution will be done, or every statement will be having a semicolon in order for the compiler to work on. Then since this main is returning something, we have to return something. Return 0, don't worry about that. We'll be discussing this returning and function returning. All this we'll be talking about. Just see that because we are in code block, these two are very important, and these two are in blue because these are keywords. These are nothing but keywords. So what this printf is doing? Printf is actually showing you some value on the console. Console is what? Console is your screen. So when I say hello first program, first C, we'll take it as first C. So if I take it as first C, then what you see, first C, and if I just compile and run, you have to save. This is star. See, if you can see star, if I do Control S, then this will be saved. Otherwise, this will not be saved. And if you run it again, it will give you the previous compiled version. So you have to save, then you do build and run, and you'll be able to see the hello first. See, if you are able to see hello first, this is hello. Okay. Now let us write our program, what we have been discussing about. This is simply the program of computing the simple interest. So let us start with the basic thing, which is the comment. Comment will be excluded. It will be ignored by the compiler, but it increases the readability of the C program. So let us start here. Just say star slash and then star slash and star. End it with star and slash. And whatever you write inside, this will be treated as a comment. So this is, say, my first program like this. I'm writing it short. You can just expand it. My first program you can write, and then you can start up, and these are the header files you have to include. This is very important. After that, let us go to the main, and inside this we'll be using the principal, the time, and all those. What you are going to see, first of all, we have to declare the variables. So I'll be writing some variables. The first variable will be, say, integer type, this p, principal value. Then we can have, say, t, time, and then we will have some float values. These will take values with point, decimal. So take r as the rate of interest and si as the simple interest. Okay, this is done. Now give some values to this p, n, and r. Give some value. So let us initialize it, p with, say, 2000, and r with some or time with some, say, 3 years, and then we say this p and t is over. Now rate of interest as say 9%. Okay. Now see, there are certain things which I'll tell you, because the result will show you whether you're doing it correctly or not. Then we'll simply use the formula. We'll use this comment again. Let's take the comment again here. Now I'll just write this is simple interest computation, or you can say formula. What the formula is, simply simple interest would be p into r into t. So for into, you have to use this star, p into r into t, and by 100. The best way is, and end with semicolon. Best way is to take them inside a parenthesis, just in order to for any precedence of the operators, we can use this. So simple interest will come. Let us show the simple interest now. So we have to put it in printf. So what is the syntax of printf? Because SI is nothing but a float. So you have to use a float. So %f, this is the data type, or you can say for the %f is for the data type float. And now here what you want to print, you have to print the simple interest. So just write simple interest. So simple interest will be printed. And let us make it more interactive, so that we can write here SI is equal to this %, right? This is our basic program. We are just computing the simple interest, and we can also take the value from the user. How? Let me just run it for you. First of all, I'm just running because I want to see if I have committed any or place some error is there, so we can just find out. So this is star, so you have to compile Control S just in order to save, build and run. Okay. So see, this has come. If you are able to see 540 point something, this is the value. Let me do a mistake. I'm trying to print the SI, simple interest, but this is my integer. So what will be the result? Control S. Let us run it again. You see, when I run it again, I get SI as 0. This is the I've shown you. This has to be %f because this has been defined as a float. It will take some decimal value. If I replace any of these, say if 2000, make it as 8, Control S. Again, run it again. You will get a different value. You will get a different value. SI equal to 0, and you have to just do it as F. Control S. Again, run. You will get a proper value. So this is 2160 point something. So this is how you get the result. This is our basic program. Here we have used various aspects, and I'll be discussing this in our continued discussion. So this was our basic program, and we have started with the comment. So comment it can be represented or can be given as in between these // and this is a multi-line. If you want to give multi-line, you have to use this because we have a compiler which supports C++ also. You can use 2/ in order to write a one line comments. These are not necessary, but it will just increase the readability of the program, and any number of comments can be written, but more comment will give you more readability. But just don't give so many comments that the program will be only having comments more rather than actually having the executable statements like this. If P and R by 100 or P and R, this is actually T we have taken. So P into N into R by 100, if somebody sees that, how he'll be knowing that it is simple interest? So this comment will do. This comment is very important. This will be actually ignored by the compiler, but for us as a programmer, and you will give program to someone else also, when he will read, when he sees that, he'll be able to understand what you are trying to do. So this is you can write anything inside this because this is simple English. Don't nest the comments. A nesting of comments means comment inside comment. This is invalid in C. And if you want to have a multi-line, as I just suggested you, this is a multi-line. This is a multi-line comment. You can write any number of lines with enter and spaces and tab. This main, which is actually a collective name of set of statements, and this main is actually everything. And this main is a function, and function is known by these two brackets, round brackets. And the statements which are written, these are written inside these braces. So we are actually taking this main. We'll be discussing about these functions in the later discussions. These are the variables. Now, these are the variables which will be taking several values or varying values in your program, and this has to have certain type because memory has to know which kind of value you are going to put in. So for the C statement, you always end with a semicolon, and what we have used here, this star and this divide, is nothing. They are nothing but the arithmetic operator. So we have used arithmetic operators. There are various arithmetic operator. We don't have exponentiation, but we'll see about that. Then we come to printf. This was very important because we want to show things on the console or on the general form of printf is like this. You have print, then format string where we used %f if you remember, and this was where we use SI. So this is the format string, and these are the list of variables. Any number of string, format string, any number of variables you can put. Any number of variables. There is no restriction. For any real values or floating point values, you will use %f. For any integral values, you will use %d. For any character values, you will use %c. So this has to be very clear because if you use say %f for integer, the value will be indifferent. In this case, you have to see the compatibility should be there. So these are different types of printf. You can print like this. You can print all these like this is %d, this is %d, %f, depending upon what you have declared. And you can also write inside this simple interest as we have written in the program. You can write this also if you want to do it in the second line. You want print to come in print, then you have to show the rate in the second line. For that, you can place this /n. So this /n is nothing but the new line character. This is how it will be shown. This /n, /t, all these are special characters which are the you can say blank spaces which it will give, blank or white spaces you can say. But we'll be discussing about all these also in detail. So now one more thing is that you can also give expression inside your printf. This is %d3. This is okay, you have learned. But this %d, what it is going to show? It is going to show you 3 plus 2, that is 5. So expression can also be given in the printf. Like this a plus b into c minus a. All the values will come here. First, this will be computed. and then it will be given to %D. See, there is a Bodmer's rule in or the operator precedence rule in C also. First this will be done, then this, then this. Then compilation and execution. Compilation and execution I have already shown you in the program. But if you are using some other compiler or say some other IDE, it may be different. But the basic idea remains the same, because ultimately compilation does what? You have set of instruction in the program, you have to convert it into the machine code, that is 0, 1. And this 0, 0, 1 will be understood by the computer in order to execute. So the compiler does this. It will change your code into the high level code into the machine language. So there are several IDEs, for various operating systems. You can have Turbo C, Microsoft C, Visual C++, Borland C++. These are under Windows. GCC, as we just saw, work under Linux. Turbo. This works in Windows also, as we'll be using GNU GCC. And then Microsoft C++, Borland C++. There are various. The various compilers have come. Various companies, various vendors have given various compilers. So if you're using Turbo C or Turbo C++, what you have to do, you just have to see that there are paths which are to be there. First of all, when you're using Turbo C and Turbo C++, there are several steps you have to take to run a C program. Start a compiler with this one, with TC bin. This can be any path, but I assume that you are able to find out the bin. Bin is the basic directory. Just select new from the file menu, type the program, save the program with F2. Say Control F9, and this extension has to be .c. Control F9, that will compile and execute the program. Then you say Alt F5, that will give you the output. Now this program will become exe because you have started with .c. This is your code, means basic code. Now when you come to .exe, that is your executable code. That is the machine code, binary. And whenever you are caught in some error, like the function printf should have a prototype, that means you have to include the header files, as we have done stdio.h. But if in the compiler or IDE, you have to go to the options and select compiler C++ options. In the dialog box that will pop up, just select CPP always in the use C++ compiler if you are using Turbo C or Turbo C++. Again select the options menu and select the environment editor, and just make sure that the default extension is C rather than CP. When you are receiving the input, that means you can receive the input by the user also. For that, you have to use scanf. Printf is to show, scanf is to take the values from the user. For example, the same program can be written in this way. Printf, enter value PNR, you can write this, and you can take the value, scanf. Rather than giving the values, you can also take the values like scanf. I'll just show you just. So this printf will print, scanf will take. But scanf, let me show you the program. Okay. Now what I'm trying to do here is, I'm going to scan up the values. I'll be taking the values from the user. So I'll just change this program a little bit so that we understand how to take the value from the user. So let me just change it. I'm not going to give all this because these are pre-given things or pre-valued or initialized value. Let me not. So what we have to do here is we'll take the value with scanf. How to do scanf? First of all, you have to say some printf. That means you want user to enter the values. So I'll take a printf, just put it here. Means I'll just say enter values, say enter P R T. Okay, then this is just take this out. I'm just showing it. I'm not doing anything here, but what I will take the value is with scanf, with the help of scanf. Scanf is, please watch it very carefully. I have to give the format string here because I'm going to take principal first. That will be %d. Principal is integer, so I have to take %d. So I'll give %d. This is %d. Then I'll take the next one, which is the time. This is again %d. So no this. Just give %. Then again %f, because I'll be taking a value of rate of interest as %f. Float. And what we have to write here is you have to write ampersand. Ampersand is the and. This is the ampersand you have to use. Ampersand p, comma, ampersand r, comma, ampersand t. Ampersand. Say this rate of interest is actually this one. So I'll take p, not I'll change it. P, t and why I have done, because p and t I have given as %d, and this rate of interest is actually my %f. That is the float value it will take. So p and this will be t, and now this will be ampersand and this will be r. I hope you got the idea. What this is doing is, ampersand is actually telling the compiler that okay, there will be a space in the memory, main memory, where this you have to name that memory location as p, and you have to put whatever value user is giving in the integer form in this location. I hope you got the idea. The location address is given. Ampersand gives you the address of that memory location. This is how we are going to proceed. So scanf is like this: %d, %f, ampersand p, ampersand t, ampersand r, right? So here we'll take the value and then we'll find out all other things will remain same. So let us see. Let us compile and run, build and run. Now it is asking for value. If you're able to see, it is asking for value. So let me give you the principal value, say 4,000. Then the time, say 3 years. And then rate of interest, say 9. Right? So this is our value, 960. So now I have taken the value from the user. This is how we take the value from the user. So what I am trying to tell you is scanf is for taking the value. We have to use this ampersand. And scanf, we can have various formation as I said. We separated it with tab. We can separate it by the space. So the three values can be separated like this. You can have a tab, you can have a slash n. There is no problem. You can use all these. So this is one more program. This is how you scanf, enter a number, scanf, and you can just show this number has come. This is also an example of. So we have C instruction. We have seen about the C instruction, and there are various type of C instruction: type declaration instruction, arithmetic instruction, control instruction. What is the purpose of these instruction? Type declarations, it declares the type of variable which are used in C program. The arithmetic instruction, in order to perform arithmetic operation between the constant variables we are going to use. The control instruction is to find out to implement the sequence of execution of various statements in C. Since the elementary C program we have seen only contains the type declaration and arithmetic instruction, we'll discuss few of them just now. So type declaration instruction, the instruction is used to declare the type of variables. So this is the instruction which we use to declare our variables. So this BS, RS, these are all variables which are declared with int, float and char. That is the memory size it will be taking, and you have to do it in the beginning of the main function in C. There can be certain variation, like that means while declaring the type of variable, we can also initialize it as like this. You can do it as I equal to 10, j equal to 25. The number of values you can give, we can declare or initialize the value. You can also have, see, this float a equal to 1.5. You can also have the expression here, but the order is very, see, the order is very important, because if you give I equal to 10, j equal to 25, there will be no problem. If you take j equal to 25 here and I equal to 10, there will be no problem. So you can just change it also. The order can be changed. But how about this? If you give a equal to 1.5 and b equal to a plus 3.1, but here the problem is, if you just change it, a will come here. But you are trying to find out first this. There is no a here. Means compiler will not know what a value is. So there will be error in this. So first a has to be defined, then you can do anything with a. And this statement would work ABCD. ABC can be given or initialized initially as 10. But if you want to do it in the same line, int a equal to b equal to c equal to d equal to 10, this is not going to work. So you have to separate it. Now we have arithmetic instruction. The C arithmetic instruction, it can contain variable name on the left hand side, that is on the left hand side of is equal to. And then you can have variables and constant appearing on the right hand side, and with plus, minus, into, and this division, there are various operators you can use. So this is kind of example. You can have AD, you have declared in the float all these values, basically variables, and now you can assign. This is left hand side, and you can assign the expression also. Whole expression can be assigned to this. So we have these as operator here. This is the is equal to is single is equal to, because double is equal to will be discussing. This is equation of, we equate or check for if those values are equal or not. These are the integer constants and these are the real constants. This is the integer variable here, and all these are the real values. So the variables and constant, these are called operands, and they are operated upon by the arithmetic operators. And in the one more thing I would like to add here, when we have a C arithmetic statement, this can be of three types. You can have integer, all these are integer. You can have float. See, all are float, and we can have mixed. See, this is float and these are integer. So you can have combination of this also. See, we are adding ABC, this is the integer with the num. ABC, num with the values which are from here. So you can have this also and you can this also. So there can be a mix of real and integer. So these are all things which we need to understand. You cannot have two values on the left hand side. That means if you have an assignment operator, you can have z equal to say a into b into c, but you cannot have a into b equal to z. You cannot have k into l equal to z. This is illegal. When you are doing addition, there are two operators you have to understand. That is division and modulo. Division and modulo means if I take 10 and 2, see 2 and 10. If I divide 10 by 2, 2 5s are 10, you get remainder as. So the division operator will give you this 5. The modulo operator will give you remainder. This is 0. So whenever you take modulo, you'll get 0. Whenever you take modulo, you will get the remainder, that is minus 5 divided modulo 2. Let us take this 2. So 2 2's are 4. This gives you minus 1. So 2 is minus 5 divided by 2, and this minus 1 is minus 5 modulo 2. Modulo will give you the remainder, and divide will give you what? The actual this. The arithmetic instruction is often used for storing character constant also, because initially and in the internal way, these are the characters, and these are characters having some value, and these values are numbers, and these numbers are called as ASCII, American Standard Code for Information Interchange. Whatever you see in the keyboard, whenever you press it, there will be a number generated. That number is actually the number which will be taken by the system, and it will understand, okay, you are discussing about F, G or plus. For example, the F has a value as 70 and G has a value 71, and you can do operation. So internally, these characters are only numbers. They are characters, and internally characters are treated as integers in your program. I hope you got the idea. Character and integers, they are no different. See, I'll give you an example. We have char xy in Z. If you give x equal to A, y equal to B, A is having a value of 97 in ASCII terms. B is having the value as 98 in the this term, ASCII terms. When you say x plus y, you are adding 97 and 98, and you are assigning to Z. So essentially, this is equivalent to adding two numbers. And you have to give the operators. You can't just believe that C or C++ would understand it. You have to explicitly write not dot but into. You have to write explicitly all the operators you want this expression to be worked on. And we don't have exponentiation here like 3 double star 2 or 3 this cap 2, but we have a power function. This power function comes from the include library, that is math.h in C. This power function, say if you want to find out 3 square, just use power 3 2 and include this math.h. This is the file which is already library file present in your C compiler. So this power function can be used for the exponential. So integer and float conversions. Whenever we are dealing with program, there are certain conversions. One is called implicit, one will see as explicit. So how this conversion take place? An arithmetic operation between an integer and integer. So if both are integers, they will give the result as integer. When we have both as real, that is the floating point values, they will give you result as floating point. But when we are dealing with an integer and real, what it will give? It will give you real. Why? Because the integer is having the lower memory requirement than the real. So the lower requirement memory or this integer will be first changed into real. That is, if you are adding 2 with 3.0 or 3.2, this 2 will be converted to 2.0, because in memory you want, say, if this is say 4 byte. So if this is 4 byte and this is 2 byte, how can you add a 2 byte with a 4 byte? This has to be converted into 4 byte, means the values has to be kept in 4 byte, then 4 byte and 4 byte can be added. So this is how it is converted. 2.0 will be first converted, 2 will be converted to 2.0, then it will be added with 3.0. So what you are going to get, these are the practical example. 5 by 2 is what? It gives you 2.5. Since both are integers, you will get only 2 because this will be truncated. You will get 2. But since 5.0 and 2, as I said, just this will become 2.0, this will become 5.0, this will become, these are already 5.0, 2.0, then you will get 2.5. What about this case? 2 by 5 is what? 5. If you divide 2, 5 is simply 5.0, 5 4 is 0.4. So you get 0.4. But what happens here? Because both are integer, this only 0 will be taken, 0.4 will be truncated. So you get 0. What about this one? 2.0 by 5. Because 5 will be converted to 5.0, 2 will be converted to 2.0. These are already 2.0, 5.0. You will get 0.4. Type conversions in assignment. When you are dealing with an assignment, then how the type will convert. See, first of all, the left hand side and right hand side, they may be of different data type. So the value of expression is promoted or demoted, which it totally depends on what is on the left hand side. If this is an integer and you have say 2.3, this 0.3 will be truncated because this is an integer, say x is an integer. But if x is equal to 2 and this is a float, x is a float, so 2 will be promoted to 2.0. Okay. See, integer I and b, we have I as 3.5, b as 30. This is an integer. This will only get 3. 0.5 will be truncated. How about b? b is 30, but this is float. So 30, this will be 30.00 and 0 something, right? So these are the values. You get 3.5, this will be truncated, you get only 3. For 30, you will get 30.000 because it has been assigned on the left hand side to the float value or float variable. And this rule applies to any expression also. See, this is an expression. Now here what happens? This ABC, all these ABC, these are what? These are simply integers. But whatever result will come, this result, say it is an integer. I don't know what it will come, but if it is an integer, the value which it will, or say if it is an integer, it is well and good because S is our integer. These are all float. These are all float here. But if these values are giving you some integer value, it is okay. But if they are giving some float value, say 8.36, only 8 will be taken by S, 3.36 will be truncated. Let us take some formal example. See, 2 by 9. 2 by 9 will give what? Because K is integer here and A is a very real number. So 2 by 9, as I just said, because 2 by 9 will give 0 point something, 0 point, any 0 point if you divide it. But we are not interested in finding that value because we know that when you have 0 point something, and if it is an integer, only 0 will be taken. A decimal, any value after decimal will be truncated. But here 2.0 by 9.0 you will get, but this whatever is computed, say 0 point something, it will be computed. 0.222 will be the value actually, 0.222. But because it is an integer, it will truncate all these decimal values. This is same with these two. 9 by 2 will be 4.5 because this is integer, 0.5 will be truncated, only 4 will come. Similar is the case with these all, because they will all give you this, they all will give you 4.5. But this is an integer. Integer will take only the integral value, decimal point, and after that will be truncated. Similar is case with this 2 by 9 because this is actually a real number. But 2 by 9 will actually give you because both are integers, it will give you 0.222, but these are integers, it will give you only 0. So 0.0 will be assigned. 2.0 by 9.0, it will give you proper values because all this will be changed to 2.0, this will be 2.0 and 9.0 already. Here what will happen? This will be 4.5. But since this is 4.5 and these two are integer, 9 by 2 will give you only 4. And this 4, when it is assigned to A, that real number, then it will become 4.0. But here the case is different. 9.0 and 2.0 will give you 4.5. 4.5 can be assigned to A. Similarly, 9.0, 2.0 can be assigned to A. And this 4.5 can be assigned to it. And you just have to see what I have explained you, that what on the left hand side you have. Depending upon that, the promotion and demotion will take place. Hierarchy of operation. Hierarchy of operation means if you have, say, 2 into x minus 3y, how it will be computed? Either this way or this way. Either this way or that way. We don't know. A divided by b star c or a by b first, this will be computed in star c. So we ought to have some hierarchy. We need to know which will be done first, which will be done later. So we have a proper hierarchy. Hierarchy is that this star and this modulo and division, these all have highest level precedence. Before that we have this also, round brackets actually. But because we are talking about the operators, these three first, then plus minus, then assignment. And there are certain things you must know. First of all, as I just said, whatever you keep inside the round brackets, that will be done first, and then the others will be done. We will explain it with an example. You have to determine the hierarchy of operations first of all and evaluate the following expression. See, first you have to do 2 into 3, star is the first, it will be 6. Then 6 by 4, it will be 1. Then next one is 4 by 4, it will give you 1. Then we have 5 by 8, it will give you 0. Then after this, you can just add these two. Add this 2 with 8, subtract this with 2, and then this 8 can be added with 0, so you have to find the hierarchy and find out the solution. So first of all, 3 by 2, first this will be done, this will be 1.5, so you will get only integral value, so 1 will be the result. Then 1 into 4 is 4. Then 3 by 8 will give you some 0.00 some value 3 for something values. I'm not interested in this because I'm able to see that only these dot, and after that value will be truncated. So I'm only interested in the 0 value. Only 0 will come. Then we have 4 plus 0, that is 4, and then 4 plus 3 is 7. So we don't have any Bodmer's rule type, here. We just have to see what kind of, I'll tell you how exactly it is done, because we have some associativity rule. But right now we don't have any Bodmer's rule, but we have various operators, and these operators are realized by the precedent. But first of all, if any algebraic expression is there, you can't just write it like this as you do it in copy pen or you have seen on the book. No, not like that. This star, this into or x has to be converted into star. This you have to put a divide or slash here. This has to be changed into star. This ABC has to be kept into the bracket, these two brackets, and you have to use for this a division sign, or you can say a slash. Here also 2 star, B star, and then keep it in the bracket so that you understand well. This again you have to use a star. So these all you have to understand, because this is not just writing things in your copy pen. This is actually writing in the program. So when you are writing a C program or any programming language, you have to use operator everywhere. Associativity of operators. So when an expression contains 2 operations, they have equal priority. Say into and star, or into and division. Then what to do? Because they have equal priority, there is a tie. So this tie, how to resolve it? We'll use the associativity. So it can be from left to right. It can be from right to left. Right to left. So left to right associativity means the left operand must be unambiguous. Unambiguous means the value, it should not be in any sub expression. Means it should be a single value. It will be single. It has to be single value, no expression. In the case of right to left, similarly right to left, we apply right to left when the right operand is unambiguous. That is, the number which comes, or the expression, or the value which comes, not expression, value which comes is not involved in any expression. I'll show you an example. 3 by 2 star 5. Just take this 3 by 2 star 5. See, if we take the division, this division. In this division, the left is 3. It is unambiguous. It is a proper number. But here we don't know. We don't know whether it is 2 or whether it is 2 star 5. So the left is actually unambiguous. It is clean. Right is not. And if we take a star, see the left hand side. If the left hand side is unambiguous, is ambiguous actually, it's because the star, the right operand is okay, 5. It is clean. But this we don't know. It is 3 by 2 or it is 2. Which we have to take? We don't know. So since this division and star, they have left to right associativity, and only this has unambiguous left operand. See, this star, division and star has left to right associativity, and this has, as we just saw, this division has left as unambiguous and it is left to right. So the operation will be left to right with division. We'll consider one more expression. See, A equal to B equal to 3. Here both the assignment operator have the same priority. This one also, this one also. So we'll see the, first of all, the both the operators. See this one. For this, the left is unambiguous, it is clean, but right we don't know whether it is B or it is B equal to 3. We don't know. For this one, we have right as clean, but left as, it can be B, it can be A equal to B. Right? We don't know. So both these have right to left associativity. Please understand, this assignment operator has right to left. Right to means left associativity. This, and only the second one, this one has the right operator, value as unambiguous. So we'll take this first. We'll take the second first. This will be applied. Let us take one more expression. Here, into and star enjoy the same priority. They have the same priority. But if you take star, left and right both are clean, no problem. If you take division, C and D, left hand side, right hand side, no problem. Anything can be taken. So both operands are ambiguous. So it depends on the compiler whether it wants to do it first or this to first. So it totally depends on the compiler what to be done first. Control instruction in C. So we have various control instruction. We'll be discussing them in detail. This actually decides the flow of control, which has to be done, which has to be done when, or whether this expression has to be done again and again. We'll be dealing with them, in quite a detail. So they are sequence control instruction, selection decision control instruction, repetition or loop control instruction, case control instructions. We have many. So these, I'm just going to skip this right now because looping, decision control, and then if, loop, while, else, all will come. That will be, we will be taking a lot of examples and explaining it. So let us summarize what we have seen. There are 3 primary constants and variable types in C, which are basically integer, float and character. The variable name can be maximum of this. I don't say this to be maximum. You can take any length. There is no restriction at all. But what I am trying to say here is the best is to keep it to 31 characters. Do not use keyword as a variable name because these are keywords. They are reserved words. An expression may contain any sequence of constant variable and operators. There is no boundation. And operators, if they have equal precedence, they are evaluated using left to right or right to left associativity. The left to right associativity means left operand must be unambiguous. It should be clean. It should not be in some sub-expression. And right to left associativity means the right of an operator must be unambiguous. The input output in C is done by scanf and printf. So this is all about this first chapter we are taking. Thank you so much. Take care of yourself.